All right, good evening. So, welcome to Intro to Statistics. We are going to continue our discussion about probabilities. We'll start with question 4 here. So, we have a section of an exam contains 4 true false questions. We have a completed exam. We have 4 answers on here. Round your answers to the nearest decimal place. Or there's 4 decimal places if necessary. And assuming all possibilities are equally likely, so it's equally likely that the answer to a question can be true or false, we're going to go ahead and do what's the probability that they're all false. Okay. I remember I'm an 80s kid, okay. When computers started getting popular, people started using them. It was really important for us to learn how to count in binary. So we're going to say 0 is equal to false, true, 1 is equal to true. And all I'm going to do is just count in binary to do this. Okay, so we're going to start off with 1, 2, 3. Those are the possibilities for the answers. They might all be false, and then we're just going to count. So we have 0, we have 0, 0, 0, 1, 0, 0, 1, 0. Okay, 0, 1, 1. 0, 1, 0, 0. That would be 4. 0, 1, 0, 1. That would be 5. Oops, I need this back. There we go. We can have 0, 1, 1, 0. That's 6. 0, 1, 1, 1. That's 7. Okay. So there we go. Now we're going to have the first value change. The first digit's going to change. Okay. It was really important for all of us to know that our powers of 2, because that was going to help us learn how to do computers. So I know all of us now in the 21st century, you guys are all perfectly capable of like coming up with all your powers of 2 and counting binary, because that was a really important thing that we had to learn how to do in the 80s. Okay. So we have that number. 1, 0, 1, 0. And if you're not saying like I know you didn't. Okay, honestly, I think the best thing that this has ever had me do was this was helpful in figuring out video games that had a lot of toggle switches as puzzles. Okay. But all I'm doing is counting in binary to count up my ideas here. There should be 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 makes 16. There are 16 possibilities. Okay, so there are 2 to the 4th, right? Because we have 4 positions. Each of them have 2 possibilities. So 2 to the 4th would be 16 possibilities total. Okay, and 1 out of those 16 possibilities, this one specifically, is that they were all false. Okay, so counting binary might be something you want to look up a little bit. Okay, again, it was really helpful in solving like Mario Brothers games where there was a lot of toggle switches that you had to figure out. That was supposed to be complicated for some reason, but that's how video game designers designed puzzles back in the 80s. So 0.0625 is the answer they're going to give us. Okay. I'm not really that likely to ask you a question like this, but 625. Okay. But that is the skill that I used in order to get through this. Was I just counted in binary to list all the possibilities, and I said, okay, how many of them were all false? One of them was all false, and I will just go ahead and check that, and then say, hooray! Assuming all the outcomes to be likely, find the probability that exactly 3 of the 4 answers is true. Aha, that's a little bit more interesting. They want 3 out of 4 answers is true. 3 out of 4 answers is true. Well, if true is equal to 1, right? If I set my true up to be 1 and my false is 0, then if I add up all of these anything that adds up to 3 is going to be 3 of the answers are true. And it could be like, it could be this one. All 3 of these are true, but the first one isn't. Okay, so all I'm going to do is just look at all of these and say, well, if I add up all of these possibilities, which of these add up to 3? Well, this one does, so there's 1. Okay, there's going to be more than that. Okay, this adds up to 1, this adds up to 2, this adds up to 2. Hey, this adds up to 3. There's another one. So there's 2. Okay, I believe we're on this one. There's a third one and a fourth one. So we have 3, 4. Okay, so 4 of these values added up, 4 of these cases added up to 3. That would be 3 out of the 4 cases would be true. And it doesn't matter which cases they want. We're just adding up all the possibilities where we have 3 answers to be true and 1 answer to be false. Okay, that's all we're doing here. So there was 1, 2, 3, 4 out of the total possibilities of 16. So we have 0.025, 0.25. 1/4 of them were true. Okay, where we had this possibility. Check, hooray, and then we could move on with our lives and then go with the next one. Assuming all the answers are equally likely, find the probability that 2 of the answers are true and 2 of the answers are false. Well, if 2 of the answers are true, they're going to add up to 2. Okay, and it doesn't really matter because the other one, there's only 2 possibilities, right? It's either true or it's false. So we either have 1s or 0s. We're just going to add up and find out which of these added up to 2. Which of these had 2 1s in it? Well, there's 1, there's 2, there's 3, okay, 4, 5, 6, and it looks like that's it. So we want 6 out of 16. Okay, to be true. Let's double check. So 1, 2, 3, 4, 5. Missed one. Oh, that's right. 3. Okay. And then 4, 5. Well, we're getting 5. It should be 6. 3, 4, 5, 6 on the other side. Okay, so 6 out of 16. They want a decimal. I would prefer, like if I was doing this face to face, I would prefer you said 6 out of 16. But since Alex is the, we're going to obey 6 out of 16. We're going to say 0.375. So 0.375. Okay, we'll check. Okay, and we're good, and we're going to move on. Okay, so that's how you do a problem like that. I do recommend making something that's going to be easy for you to follow, so because you have to go through all of this stuff to find everything, and we're just going to check all of that. Okay, and all you have to do is count them up. We're going to make a table. We're going to count up the different cases. Okay, so moving on. Okay, now this one. All right, we have automobile insurance company divides customers into 3 categories: good risks, medium risks, poor risks. Hopefully you are a good risk. We have a total of 11,000 and some odd customers. We have so many good risks, not so many medium risks, and a couple of poor risks. That's, as an insurance company, this is the kind of thing you would want. Okay, as part of an adult, one customer is chosen as part of an audit. Customer is chosen at random, graduates into 4 decimal places. What's the probability that this customer is a good risk? Okay, so all we're going to do is we're running an experiment. Okay, just as an empirical probability. Okay, let me go down a little bit. Scroll back down, and we had 11,158 experiments. Okay, so let's go ahead and put down. We have 11,158 experiments. Of these 11,158 people, how many of them are considered good risks? We have 7,800 of them are considered good risks, and we're just going to calculate that and say well, that's our good risks. Okay, and it's all we're doing with this. That's all they want us to do. So we're just going to say 78,000. No, it's clear. 78,000 divided by 11,158. 11,000. I don't like that at all. So 7,000, 7,800, 11,158. Okay, so assuming that I'm getting my digits correct here. Okay, how many decimal places do they want? 4 decimal places. So we have 1, 2, 3, 4. So I'm going to say 0.6991. 0.6991. 0 here for the sake of the nursing students, and then we'll have 0.6991 is our probability. So 0.6991. What if you didn't put the leading zero? It's not going to matter. Okay, I'm doing it because it's good practice, especially for the medical people. But if you don't do it, nobody's going to get mad at you. They might, the computer might yell at you a little bit, but there are worse things that could happen in life. Okay, what is the probability that they're not? What is the probability that a customer is not a poor risk? Well, if we have a poor risk and not a poor risk, right? Whatever this probability is, this should add up to 1. Okay, because either they're a poor risk or they aren't. But this should add up to 1. This is called the complement rule. Okay, so this is called the complement rule. Okay, the complement just means not the thing that we were talking about. Okay, so all we're going to do is we're going to calculate, well, what's the value, what's the probability of a poor risk? Okay, we have 941 out of these 11,158 people. Okay, there's a total of 11,158, and we're going to subtract off 941 people who are poor risks and say that that is equal to 11158 minus what is this, 941 people who could be poor risks, and that's going to be 10,217. This is all divided by the 11,158. Okay, and that's going to be divided by 11,158. Okay, equals, and then we're going to have 4 decimal places, 0.915. We'll call that a 7, 0.9157. Okay, so 0.9157. Okay, so I hope that makes sense where it's 1 minus the total. You could also have said 1 minus 941 over 158 there. So we could also check 1 minus. Then we have 941 divided by 941. There we go, 941 divided by 11158. We should get the same value. Hey, look at that, 9157, 9157 as far as our values go. So 0.9157. And that's going to be our answer. So you could have done this in 2 different ways. I took the total and I subtracted out the bad risks, and I took whatever was left and made that dividing. Or we said 1 minus the number of poor risks and the probability of a poor risk. And we got the same answer either way. It doesn't matter. Okay, so either way you do that is just fine. So we're going to say 0.9156. We're going to say 19157 because we're going to round to 4 decimal places. Okay, so we'll check that and then we'll go on with our lives. Okay, say continue. Okay, I think I have time for one more before I should probably stop this one because I don't want to make the videos too long. But we have, okay, a company audit shows that 459 bills were sent out. 331 of them were paid on time. Good for them. 136 were paid up to 30 days late. It's not too bad. 71 were paid between 31 and 90 days late. I know a couple of people that are not going to be happy with their credit scores. And then 11 people remained unpaid after 90 days. They're going to get a call from a collection agency, I guess. One bill is selected at random. What is the probability that the bill is paid on time? Okay, so again, all we do is we did an experiment. We had 549 experiments. The success is they were paid on time. Okay, it's good. Everybody's happy. You don't get phone calls, and the company gets their money. Everybody's doing okay. So it said that 331 were paid on time. Out of how many bills do we have? 549. Again, if I was doing this as a face-to-face class, that would be the correct answer. Okay. Round your answer to 4 decimal places. Delightful. Okay. So we're going to say this is 331 divided by 549. Okay. 4 decimal places. 0.6029, it looks like. So this is 0. Oh no. Okay. 0.6029 to 4 decimal places, and we'll go ahead and check and say that that'd be great. Okay. I don't know. Oh, that was not paid on time. Okay, so all I'm going to do is take 1 minus this. See how these problems kind of fall together? The bill is not paid on time, which could have mean that it was, it could have been never paid. We don't know. So we're just going to take 1 minus this previous value that we got here. Okay, so 1 minus, the way you do that, the clever way you do that is the second function answer. That's the last number it had in there. So 1 minus this horrible thing right here, that's how we're going to get that value. So we're going to say 0.397. That'll be a 1. Okay, so that'll be 0.3971. Okay, does that make sense? Check, hooray, and then we'll go on with our lives. Okay, so hopefully that's not too terrible of a probability introduction, and try to do some of this homework, try to do some of these problems. Okay, they'll reshuffle them and give you brand new ones for yours. So I'm not too concerned that I've done a lot of your homework, but like I said, you should practice these on your own as well. If it helps for me to talk to you as you're doing these, please do that. Whatever gets you through it. But I will see you in the next video. Thank you.